Hi everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 3, which is the Pure Mathematics 3 for May-June 2023, and the code is 9709/33. Okay, so let's get started. Now, question number 1, solve the equation ln x plus 5 equals to 5 plus ln x. Give your answer equal to 3 decimal places. So first of all, I will rewrite the question. Alright, so this ln x can be moved to the other side, becomes minus. And then we have a formula for the ln a minus ln b. It is ln a over b. Okay, so therefore, the left-hand side can be combined to be one ln, which is ln of x plus 5 divided by x, then equals to 5. Now, next step is to eliminate the ln by taking e both sides. So when you take e ln, okay, so we have another formula here. E ln a is basically a. Alright, so therefore, the left-hand side, I will just direct write x plus 5 over x. Then the right-hand side will be e5. So when we need to solve the equation, that means we need to find what is the x value. Alright, so for this case, this denominator, the x will be moved to the right hand side. So I will get x plus 5 equals to x times e degree 5. So it means that the e degree 5 is actually a constant. And now we need to get back our x. So what to do is I will move this x on the left hand side to the right hand side. So 5 equals to x e5 minus x, and at the same time now the x is in common. So we can factorize the x, which is e5 minus 1 multiplied by x equals to 5. And then my x will be 5 divided by e5 minus 1. And now using calculator, you will be getting 0.034, which is correct to 3 decimal places. Alright, so that's all for the question number 1. Question number 2. Find the quotient and remainder when 2x degree 4 minus 27 is divided by x squared plus x plus 3. So to get the quotient and remainder, the easiest way is to use the polynomial division. So now your function only has two terms. The first term is 2x degree 4, but we know that after degree 4 is supposed to be degree 3. So I will add on 0x degree 3, then followed by 0x degree 2, plus 0x, then minus 27. Okay, and the divisor is quadratic function, so which is x squared plus x plus 3. Now, to get the 2x degree 4 from x squared means that we need to multiply x squared by 2x squared. So I will write 2x squared over here. Then 2x squared multiplied by x squared, it will be 2x degree 4. 2x degree 2 times x, it will be 2x cubed. 2x squared times 3, it will be 6x squared. Then now minus. First term will be 0. Second term, 0x cubed minus 2x cubed, it will be negative 2x cubed. Same goes to the next term, 0x squared minus 6x squared, it will be negative 6x squared. Okay, then we bring down the 0x. And now it's the same concept. To get 2x cubed from x squared, we need to multiply x squared by negative 2x. So negative 2x. Now negative 2x multiplied by x squared, it will be negative 2x cubed. Negative 2x multiplied by x, it will be negative 2x squared. Negative 2x multiplied by 3, it will be negative 6x. Okay, again, minus. So minus 2x cubed minus 2x cubed, it will be 0. Second term, minus 6x squared minus 2x squared, it will be negative 4x squared. And then the last term, 0x minus 6x, it will be plus 6x. And now we bring down the negative 27. So in order to get negative 4x squared from positive x squared, I need to multiply with negative 4. So then I will do the expansion. Negative 4 times x squared, it will be negative 4x squared. Negative 4 times x is negative 4x. Negative 4 times 3, it will be negative 12. Okay, again now minus. So from here, first term will be 0 because they are the same term. Second term, 6x minus 4x, it will be 10x. Then the last term, minus 27 minus 12, means minus 27 plus 12. Then you will be getting minus 15. Okay, so by looking at the degrees of x in this step now, the degree of x is 1. Okay, but then the degree of the divisor is 2, which means now we can stop doing this polynomial division. And hence we are getting the quotient and remainder. So the quotient is 2x squared minus 2x minus 4, and the remainder is 10x minus 15. Okay, so this is how we get the answer. Right, now question 3. On a sketch of an Argand diagram, shade the region for whose points represent complex number z, satisfying the inequalities modulus of z minus 3 minus I less equals to 3, and the modulus of z greater equals to z minus 4i. Okay, so for your information, the first modulus or the first inequality is actually referring to the circle. So for the circle, we have to factorize the minus right after the z, then in order to get the center. Okay, so from here I know that this is a circle with center 3, 1, because 3 plus 1i. And then the radius will be 3 units. Okay, so then for the next inequality, we need to get the point. So I will change to general form, which is z minus 0 plus 0i greater equals to modulus of z minus, instead of the 4i, you write 0 plus 4i. So from here, right, I will get 2 points. The first point from the left hand side is 0, 0. Then the second point from the right hand side will be 0, 4. So now let's sketch a graph or the complex numbers. So for the first one, it will be a circle with center 3, 1 and radius 3. Okay, so when radius 3, 1, I know that, let's say here is a circle. I'll draw the circle first, then it will be easier. Then only I label the XY axis. Maybe you can just use protector to draw it. Okay, so since the center is at 3, 1, that means this is 3, 1. Here is 3, 1. That means here is going to be 3. This is 1, and then the radius is 3. So since the radius is 3 and the center is 3 as well, that means it will be touching the, at this point, it will be touching the y-axis. Okay, let me okay, hang on please. Okay, so when you draw the the Argand diagram, alright, we do not label xy, but we label imaginary axis and real axis. So here is going to be 0. Then since the radius is 3, so I know that here is 1. Okay, so the highest point here is going to be 4 because the radius is 3. then this point is going to be -2. Alright, so this is my circle. Alright. Okay, so from here I know that the second point, the second inequality consists of 2 points, 0, 0 and 0, 4. Okay, so the midpoint of these two will be at 0, 2. So let's say here is 0, 2. Alright, so now when you look at the inequality, there's an equal sign. That means I can just draw a straight line. So the first one is actually the region inside the circle, because less than equals to 3. For your information, all the points on the circumference of the circle is actually equal sign. When it is less than, means all inside the circle. Now we know that the region will be inside the circle, but then what about the second inequality? So second inequality means the distance, the modulus means distance, from the general point to the origin will be greater and equals to, from the general point, the distance from the general point to the 0, 4. Okay, so that's why I use the solid line here, because when you are drawing solid line means that it is equal sign. So now I just need to consider greater than. So now if let's say we consider this point, okay, or I will just take another point. Let's say I consider this point. Alright, on here. The distance to the origin is so short compared to 0, 4. Okay, but then we need to get the distance from general points to origin is greater than the other distance. So that means it will not be below the straight line. Okay, so therefore you can just double check. I take another point. Let's say, for example, the point is over here. So the distance from this general point to origin, okay, which is here, for example, here, it is longer than the general points to 0, 4, which means you can accept all the points above this horizontal line. Okay, so this is how we decide the region for the inequalities, which means now my region is basically above the horizontal line. Okay, and if you need to label the circle equation is basically z modulus z minus 3 plus I equals to 3. Then this line is modulus z equals to modulus z minus 4i. Okay, so that's all for this question 3. Question 4. The parametric equations of a curve are x equals to cos theta over 2 minus sin theta and y equals to theta plus 2 cos theta. Show the dy dx equals to this expression. So now x equals to cos theta over 2 minus sin theta. Now I need to get dx d theta. So to get dx d theta, we need to refer to quotient rule. d over dx u over v, which is same as over v squared vu prime minus u v prime. Okay, so now I will square the denominator first. Then now I rewrite my denominator, which is my v. Differentiate cos theta, it will be minus sin theta. Then minus, keep the u, means keep the numerator. And now differentiate the denominator. So when you differentiate 2, it will be 0. Differentiate minus sine theta, it will be minus cos theta. Okay, so from here, I will simplify my numerator. So I will do expansion. It will be negative 2 sine theta plus sine squared theta plus cos squared theta. So now, sine squared theta plus cos squared theta is basically 1. Excuse me. So this is the dx over d theta. Now, from the y, we need to get dy over d theta. So dy over d theta is 1 minus 2 sine theta. Therefore, our dy over dx will be dy over d theta times d theta d theta over dx. Now, for your information, d theta over dx is 1 over dx over d theta, which means this is 1 minus 2 sine theta. Then 1 over dx d theta. This is your dx d theta. So now when you take 1 over, means you need to swap the numerator and denominators. So I will just direct switch the numerator and denominator. Okay, then from here, I can factorize, or I can cancel off 1 minus 2 sine theta. So at last, we found the form. Okay. Now, for next question, number 5. The diagram shows the parts of the curve y equals to x squared cos 3x, where the x is defined from 0 to 1 over 6 pi, and its maximum points M, where x equals to a. Show that a satisfies the equation a equals to 1 over 3 arctangent a over 2 over 3a. So since your a, x equals to a, is the x coordinates of the maximum point, maximum points means we need to get dy dx first. So I will start with dy dx. Now, to differentiate this x squared cos 3x, this is basically product's rule. So d over dx uv equals to uv prime plus v u prime. Right? So when you keep, okay, this is your u, so keep the x squared. Differentiate cos 3x, differentiate cos is minus sine. Rewrite the 3x, and when differentiate 3x, it will be 3. That is a v prime. Plus, keep the cos 3x, which is our v here, differentiate the u. So when you differentiate x squared, it will be 2x. So from here, I can rearrange, or I can just open all the brackets. Then it will be negative 3x squared sine 3x plus 2x cos 3x. And now when you look at the question, maximum points M occurs when x equals to a, which means when x equals to a, dy dx equals to 0. Okay, so from here I will write 0 equals to negative 3a squared sine 3a plus 2a cos 3a. And now from this equation, we need to prove, or we need to show a equals to 1 over 3 inverse tangent 2 over 3a. So in order to get inverse tangent, before we get inverse tangent, we must have found the tangent first. In order to get tangent, okay, tangent a is sine a over cos a. So it means now, right, I need to divide the whole equation by cos. So I divide the whole equation by cos 3a because you have sine 3a cos 3a over here. So 0 equals to negative 3a squared sine 3a over cos 3a plus 2a cos 3a over cos 3a. Okay, then I will get 0 is negative 3a squared tangent 3a plus 2a. So I don't want to have any minus. When you look at here, there's no minus, right? Both plus. Then I will move this 3a squared tangent 3a to the left hand side. And then now the a can be cancelled off. Okay, this a cancels off, this still have a. And when you look at the question, we need to get 2 over 3a before the inverse tangent. So this 3a will be moved down. Then I will get tangent 3a equals to 2 over 3a. And then move the tangent to the other side. So 3a is inverse tangent 2 over 3a. And lastly, move the 3 to the right side. So my a will be 1 over 3 inverse tangent of 2 over 3a. Okay, so we have proven, or we have shown the given form. Alright, so we have done for this part. Let's look at the next part. Now B, use an iterative formula based on the equation in A to determine A correct to 2 decimal places. Give the results of each iteration to 4 decimal places. So now I have to rewrite my A and add on the subscripts to make it to a formula, iterative formula. So it will be A. So instead of A, you write A n plus 1 equals to 1 over 3 inverse tangent 2 over 3 an. Okay, now when you look at the question, your m is when x goes to a, and then the a is in between 0 and 1 over 6 pi. So you can choose any values for the a naught. Okay, you can choose 0, 1 over 6 pi, or any other numbers. So I will take 1 over 6 pi, or maybe you can just take half of 0 and 1 over 6 pi, which is 1 over 12 pi. Okay, any values will do. So now I will choose a naught is 1 over 6 pi. Then from here I will get a1, which is 1 over 3 inverse tangent 2 over 3 times 1 over 6 pi. Now, when you count this value, make sure you change the mode of the calculator to radians. Okay, and now for the result of each iteration, it will be 4 decimal places. So now we start with 0.3017. Then calculate a2. It will be 1 over 3 inverse tangent 2 over 3 times 0.3017. Then here is going to be 0.3819. Now, your answer 2 decimal places. So make sure you get 2 same digits after the dot. Okay, so now they are not the same yet, therefore we have to continue. So a3 will be 1 over 3 inverse tangent 2 divided by 3 bracket 0.3819, and you will get 0.3502. So again, this is different. So a4 1 over 3 inverse tangent 2 over 3 bracket 0.3502, and this is 0.3624. Okay, then proceed, because just now 35, now 36. Then A5 will be inverse 1 over 3 inverse tangent 2 over 3 brackets 0.3604, and you will get 0.3576. Okay, so just now 36, now 35. So add one more calculation. 1 over 3 inverse tangent 2 over 3 bracket 0.3576, and now you get 0.3595. Okay, so when you look at here, 0.35, here's 0.35, exactly the same. So now our final answer is based on the last calculation, the third digit. So if this digit is 5 and above, then you round up, which means now we have to round up. So your final answer will be 0.36, correct to 2 decimal places. Okay, now question 6a. Express 3 cos x plus 2 cos x minus 60 degrees in the form of r cos x minus alpha, where r is greater than 0 and the alpha is between 0 and 90 degrees. State the exact value of r and give alpha equal to 2 decimal places. Alright, so for this case, we need to simplify the second term first. Alright, or I would say we need to simplify the whole expression first, because if you need to express in r cos x minus alpha, you should have the term that consists of cos and sine. The first term must be cos and the second must be sine. But now here you have both cos. So we need to simplify first. Now, first term we rewrite. Second term, take out the 2. And now apply this formula. So you have cos x minus 60 degrees. Refer to cos A minus B. Alright, so it will be cos A, cos B, plus sine A, sine B. So by comparing the cos A minus B and cos x minus 60, means that your A is x, your B is 60 degrees. So I will get cos x, cos 60 degrees, plus sine x, sine 60 degrees. Okay, now simplify. Cos 60 is half. So I will get half cos x. Sine 60 is square root 3 over 2. Okay, but then don't forget you still have the 2 outside the bracket. So times in the 2. So basically the 2.5 will be cancelled off. Alright. And then now I can just add on the cos. So here is 3 cos x. This is plus 1 cos x. That means I'm getting 4 cos x. Plus square root 3 sine x. Okay, so we can express this in r cos x minus alpha. So 4 cos x plus square root 3 sine x equals to r cos x minus alpha. So when here is cos, the first term must be cos. Therefore, this is our A and this is our B. So now our r is square root of A squared plus B squared, which means 4 squared plus square of square root 3. Then you will get 16 plus 9, which is square root of, sorry, this is not 9. Square of square root 3 is 3, not 9, okay? So this is plus 3. That means your r is square root 19. And then the alpha is inverse tangent b over a. So which is square root 3 over 4. And now you need to leave your answer in degrees and correct to 2 decimal places. So it will be 23.41 degrees. So at last, I will just write down the original question, 3 cos x plus 2 cos x minus 60 degrees. It will be r, which is square root 19, cos x minus 23.41 degrees. Okay, now B. Hence means use the previous answer. Solve the equation. So just now, you were given 3 cos x plus 2 cos x minus 60 degrees equals to square root 19 cos x minus 23.41 degrees. Okay, now you need to solve this using the previous answer for theta between 0 and 180 degrees. So 3 cos 2 theta plus 2 cos 2 theta minus 60 degrees equals to 2.5. I will let my x be 2 theta. Okay, so let x equals to 2 theta. That means my left hand side for this new equation will be square root 19 cos 2 theta minus 23.41 degrees equals to 2.5. So now my cos 2 theta minus 23.41 degrees will be 2.5 over square root 19. Okay, now you need to bear in mind that your theta is between 0 and 180 degrees. Okay, now we are solving 2 theta minus this. So it means that 2 theta will be between 0 and 360 degrees. And then when you minus 23.41 degrees, okay, so the left hand side becomes negative 23.41 degrees. And then the right hand side, you have to minus 23.41 degrees from 360 degrees. So it will be 336.59 degrees. Okay, so now we can accept all these values. So now, and one more thing is cos is positive. So when cos is positive, according to quadrant, it will be first and last quadrant. So now I will get the basic angle from calculator. Inverse cos of 2.5 over square root 19 is 55.003. Okay, here is also 55.003. I give more decimal places because this is a working. So now we can accept the value from negative 23.41 until 336.59. That means I will get first angle 55.003, and then the second angle is 360 minus 55.003. Okay, this is equal. So 360 minus 55.003, I will get 304.997. Okay, so now my 2 theta, move the negative 23.41 degrees to the right side first, becomes plus. So when it is plus, you will get 78.4125 degrees, and the other one is 328.407 degrees. And right, when you look at the previous step, just for information, when you look at the previous steps, these two angles are in the interval. That means we are safe. Okay, so we have to make sure the values of 2 theta minus 23.41 degrees will be in between these two values. Then that means you are getting the correct answer. So then theta will be just these two values divided by 2. You will get 39.2 equal to 1 decimal place, and the other one is 164.2 degrees. So this is the solution for part B. Okay, now the next question, 7a. Use a substitution u equals to cos x to show the integration of sine 2x multiplied with 2 cos x dx, the x from 0 to pi equals to integrate 2u e 2u du and the u from -1 to 1. So this is the substitution method. Now let's u equals to cos x first. Firstly, we need to change the dx. So I need to get du over dx, which is minus sine x. Alright. Then now this sine 2x later can be changed to 2 sine x cos x. That means I am moving this dx to the right side. So du negative du is sine x dx. Alright. So limits the x equals to 0. So when x equals to 0, your u is cos 0, which is 1. When x equals to pi, u is cos pi. Cos pi is minus 1. So from here, 0 to pi sine 2x. Now this sine 2x I can change to double angle formula. Sine 2a is 2 sine a cos a, whereby my a is the x. Means that I will be getting 0 to pi. The sine 2x itself will be changed to 2 sine x cos x. That exponential 2 cos x dx. Okay, and then from the previous step, sine x dx. So this sine x will combine with the dx. I will change to negative du. So I will change to then negative du. Okay, and then you still have the cos here. This cos x is basically the u, the exponential 2u. So now from here, okay, one more thing. When we change the u, make sure limits must be changed as well. So now, when your x is 0, lower limit, the u is 1. So I will write 1 here. When the x is pi, the u is minus 1. So basically, I'm getting this now. So integrate 1 to minus 1, negative 2 u e to u du. But then when you compare to the answer, okay, compare with the answer, I found the 2u e to u du, but then there is a negative, and I noticed that my upper limit is 1, lower limit is minus 1. So we have a formula. If you need to change the limits, right, if you need to interchange the limits, it will be negative of the function of the integration after you interchange the limits. So now with this negative, right, I need to change the limits. This is BA. Okay, that means the lower limit is A. After you've taken out the minus, the lower limit becomes upper limit. Then the original upper limit becomes lower limit if there is a minus of the integration. So now I have the minus over here. This is my minus, which means I can interchange my limits, which means I will be getting minus 1 to 1, 2u e 2u du. Okay, so this is the working to show the integration in terms of u. Alright, so now B, hence means use the previous form. Find the exact value of this integration. So I'm going to use the new integration form to solve the integration. So integrate 0 to pi sine 2x e 2 cos x dx. This is basically same as minus 1 to 1. Okay, just copy this. Minus 1 to 1, 2u e 2u du. Okay, so when you look at this integration, right, first term is 2u, second term is e 2u. So we can integrate this using integration by parts because it is multiplication of two terms. So according to integration by parts, integrate u dv over dx, it will be uv minus integrate v du over dx. This is for indefinite integral. And now we have limits. Therefore, with limits ab, then you just need to add on the limits for all the terms. Alright, so now to decide the u is always the algebraic. Algebraic means polynomial. So now you see, this is dx, here is dx, therefore u dv dx. But now here is du, which means I will, instead of u in the by parts formula, I will change the u to probably another letter, let's say w. Okay, I use another letter to replace the u in the formula. So I will let w equals to my 2u, or w is to replace the u in the formula. And then dv dx, I will change to dv over du because you are integrating with respect to u. Then this is e to u. Now, we need to differentiate the w to get dw over du. Okay, instead of du over dx here. So we need to get dw over du. This is 2. And then the v is to integrate e to u. So when you integrate e to u, you just rewrite the whole e and divide by the differentiation of the power of the e. So when you differentiate 2u, it will be 2. Okay, and then now use the formula. So this is, instead of uv, now becomes wv. So it will be 2u times e to u over 2 with limits minus 1 and 1. Minus, integrate from minus 1 to 1, v du dx now becomes v dw over du. So e to u over 2 multiply with 2 and then du here. So now I can simplify the 2 and replace the u by 1 first. So I will get 1 bracket e squared minus, when the u is minus 1, so minus 1 times e minus 2. Okay, and same for the next part, the integration. The 2.5 can be cancelled off. Means that I just need to integrate e to u. So e to u, the answer is the v here. That means I will just rewrite e to u over 2, the limits from minus 1 to 1. And now, the first term, 1 times e squared is e squared. Minus minus is a plus, e negative 2. Then this over 2, you can take it out. So negative half, bracket, bring in. So e 2 minus e negative 2. Okay. So from here, when you open the brackets, I get e squared plus e negative 2. Then here is negative half e squared. The minus and minus becomes plus half e power negative 2. Now just combine the first and third term. So e squared minus half e squared is half e squared. And then plus e negative 2 plus half e negative 2 means plus 3 over 2 e power negative 2. Okay, so now from here, you can factorize a common term, which is a half. then you get e squared plus 3e negative 2. So this is the solution of this question. Okay, question 8. The variables x and y satisfy the differential equation. dy over dx is y squared plus 4 over x times y plus 4. For x greater than 0, it's given that x equals to 4 when y equals to 2 square root 3. Solve the differential equation to obtain the values of x when y equals to 2. So it means that now our concern is to get the x value when y equals to 2. So dy dx equals to y squared plus 4 over x bracket y plus 4. Okay, so now we need to separate the variables. Keep the y on the left hand side and keep the x on the right hand side. So from here, for the left hand side, we need to split it into two terms. So it will be y over y squared plus 4 dy plus integrate 4 over y squared plus 4 dy. That equals to integrate 1 over x dx. Now, for the left hand side, I'm going to use ln. Okay, so from here, for your information, when you need to use ln, integrate f prime x over fx, it will be ln fx plus c. So now I will rewrite y squared plus 4. Differential y squared plus 4 will be 2y. But to get back the y, I have to times half outside. And for the next one is going to be inverse tangent. So which is a over a squared plus x squared dx. Then I will get inverse tangent x over a plus c. Okay, so from here, the y squared plus 4, I will change to y squared plus 2 squared dy. And then my a is 2, so I will write 2. After that, I will write another 2 outside. Then right hand side is 1 over x dx. So from here, it will be half ln y squared plus 4. And then the second term is the 2 remains. Then use the inverse tangent y over 2. That equals to ln x plus c. Now, when x equals to 4, your y is 2 root 3. So when x equals to 4, y is 2 square root 3. So now replace both values. So 2 square root 3, you square it, and then plus 4, it will be 16. Plus 2 inverse tangent, right? So when you replace the y by 2, 2 square root 3 over 2, it will be square root 3. Then equals to ln 4 plus c. So just replace directly and solve. So now your c is, okay, half ln 16. Okay, half ln 16, this half you can move out because we have a formula here. A ln b is ln b to the power of a. So I will write half, this is degree half, then plus 2 inverse tangent square root 3. This ln 4 move to the other side because minus ln 4. So 16 power half is 4, alright? So first and last term cancel off. You will get 2 inverse tangent root 3. Okay, now inverse tangent root 3 is basically pi over 3. Therefore, this is 2 pi over 3. That's your c. Once you found the c, substitute back into your equation, your general solution. Right? So now our purpose is to get the x value when y equals to 2. So when y equals to 2, so half ln 2 square plus 4, 2 square is 4, 4 plus 4, 8, equals to 2 inverse tangent, 2 over 2 is 1, that equals to ln x. Here I will not write the modulus. If you want to write the modulus, it's okay. But if you are sure that the x is positive, then you can just leave it, okay? So it is to make sure that the x is positive. So now ln x, this is ln, this half move up, becomes a power. So square root 8. Then, okay, there is a mistake over here. This is plus, okay, this is plus. So here I will write plus. Then plus 2 inverse tangent 1. Inverse tangent 1 is pi over 4. Then this 2 pi over 3 will be moved to the other side. So minus 2 pi over 3. Okay, so now my ln x is going to be ln square root 8. So 2 pi over 4 minus 2 pi over 3, you get pi over 6. And by looking at the question, you need to find the x values. Okay, so since you have ln here, I can just get the exact value for the x. So now my x is basically e ln square root 8 minus pi over 6. Now for your information, e ln a is a. Okay, or before that, ea minus b is basically ea over eb, or you can say that it is ea plus negative b as well. Okay, so we have few forms. So from here, I will say that the first one is e ln square root 8 multiplied with e negative pi over 6. So e ln square root 8 is actually square root 8. Then the square root 8, we know that square root 8 is square root 4 times 2. So this is square root 4 times square root 2, which is 2 square root 2. Okay, so that is your x value. Alright. Okay, so now we move on to next question. Question 9. The lines L and M have equations. Okay, these two are the equations for L and M. Relative to origin O, the position vector of the points P is 4i plus 7j minus 2k. A, given that L is perpendicular to M and that P lies on L, find the values of the constants A, B, and C. Okay, so now L is perpendicular to M. Let's say this is L, this is M. So L you have B1. So this is your B1. Okay, M you have B2. And here is your direction vector for B2. Now, when they are perpendicular to each other means that B1 is perpendicular to B1 is perpendicular to B2. Okay, so I will say BL, probably BL dot BM equals to 0. So I write BM and BL better because they are perpendicular to each other. So now the first one is CI minus 2J plus 4K, means 4, C minus 2, 4, dot 2 minus 3, 1, equals to 0. Okay, so from here, use a we use a scalar product formula. Just just multiply. Okay, just multiply, and plus all together. That is the scalar product formula. So I will get 2c plus minus 2 times minus 3 plus 4 times 1 equals to 0. So from here, 2c plus 6 plus 4 equals to 0, which means 2c equals to minus 10, and hence your c is minus 5. So we have found the c. And now, given that p lies on L, okay, that means the OP, this is the OP, is same as the R of the L. Alright, so now OP equals to RL. So my OP, 4i plus 7j minus 2k. So I will write 4i plus 7j minus 2k equals to my RL. My RL I will write in vertical form. So AI 3j bk, I will write A 3b. Okay, plus lambda c minus 2, 4. So lambda, I already found the c, so c is minus 5, 2, then, c minus 2, 4. So minus 2, 4. Okay, so from here, we need to find the lambda. So the lambda can be found using second formula, the second row. Alright, so I will write 7 equals to 3 minus 2 lambda. When you look at the second row here, which is the coefficients of the j, then from here, 2 lambda, this minus 2 lambda move to the right side, this 7 move to the left side, the minus 2 lambda move to the left side, and the 7 move to the right side. I will get 3 minus 7, which is minus 4. Hence, my lambda is minus 2. So now I substitute this lambda into the first row and the third row to get A and B. So now 4 equals to A plus negative 2 times negative 5. So from here, my 4 equals to A plus 10. Therefore, my A is minus 6. Okay. And now, from the third equation or third row, minus 2 equals to B plus lambda times 4. So which means minus 2 equals to B minus 8. Therefore, the B is minus 2 plus 8, which is 6. Okay, so these are the three unknowns. So I can just rewrite my A is minus 6, my B is 6, and then my C is minus 5. So this is the solution of this question. Okay, now part B. The perpendicular from P meets line M at Q. The point R lies on PQ extended with PQ ratio. The ratio of PQ to QR is 2 to 3. Find the position vector of R. Okay, just now, I let the vertical line be M, the horizontal line be L, or the slanted line be L. So vertical line as M, this is my M, this is the L. Now P meets line M as Q. So the P just now, the P is on L. So let's say this is my P. Okay, so P meets the M at Q. That means here is a Q. And then the R lies on PQ extended. So PQ extended means somewhere here. And such that the ratio PQ to QR is 2 to 3. So here 2, here is 3. Then now you need to find what is your OR. Okay, so from here, firstly, I need to find what is my OQ. Okay, so the OQ, the Q is the intersection between is the intersection points between the line L and line M. So now I will rewrite my line L. My line L is basically, okay, replace the A, replace the B, replace the C, right? So I will get minus 6, 3, 6 plus lambda of minus 5 minus 2, 4. And then my RM is also given 1, 2, 3 plus mu 2 minus 3, 1. So now since we need to find the intersection point, so RL equals to RM. Then I will open the brackets. The RL first row will be minus 6 minus 5 lambda. Second row is 3 minus 2 lambda. Third row 6 plus 4 lambda. That equals to, for the RM, first row is 1 plus 2 mu. Second row 2 minus 3 mu. Third row 3 plus mu. Okay, and I will let the first equation, second equation, and the last row is the third equation. Now to get the intersection point Q, we need to find either lambda or mu. So from here, to simplify the simultaneous equations, I will choose a second and third. You can choose any two equations. So second equation, I will multiply by 2 in order to get the lambda value. So it will be 6 minus 4 lambda equals to 2 times 2 will be 4. Then 3 mu times 2 will be 6 mu. That is my fourth equation. Now my second equation has been changed to fourth equation. Means that now I will use third and fourth equation to solve the unknowns. And now I notice that for the left hand side, I have 4 lambda and minus 4 lambda. So I can just direct add these two equations to eliminate the lambda. So the third plus fourth equation means that I will be getting 6 plus 6, 12. The 4 lambda plus minus 4 lambda will be 0. Then for the right hand side, 3 plus 4 will be 7. So mu plus minus 6 mu, it will be minus 5 mu. So now from here, I can move my minus 5 mu to the left hand side. It will be 5 mu. Then my 12 will be moved to the right side. So 7 minus 12 is minus 5. Therefore, my mu is minus 1. Okay, after you have found the mu, no need to solve for the lambda because I can just substitute into Rm to find the point on the line M. So now my Rm is 1, 2, 3 plus negative 1 multiplied with 2 minus 3, 1. That means my first row is 1 plus minus 2, which is, okay, I do step by step, 1 plus minus 2. Then 2, the minus 1 times minus 3 will be plus 3. Then the last row, it will be 3 minus 1. Then at last, it will be minus 1, 5, 2. And this is my OQ. Okay, because the intersection point and the Q is on the on both lines. The intersection point is a Q. So now I have found my OQ with position vectors minus 1, 5, 2. But then when you look at the question, we need to find OR. Okay, so now use the ratio to solve. So PQ ratio to QR is 2 to 3. I can say that the vector will be the same. So vector PQ to QR will be 2 to 3 as well, which means PQ over QR is 2 to 3. Okay, on other words, 3PQ equals to 2QR. So with this, we use the definition of vector PQ. Vector PQ is OQ minus OP. Then vector QR is vector OR minus OQ. Alright? Or probably I can just, these two I move down. It will be better. It will be easier. Then no need to solve so many terms. So I need to find OR later on. So this one move up. This whole term move to the other side. Becomes 3 over 2. Okay, this one is easier. So I will write this is same as QR. So my QR, vector QR is OR minus OQ equals to 3 over 2 of PQ is OQ minus OP. Then from here, my OR, this minus OQ will be moved to the right side. So it becomes plus. So plus 1 OQ plus 3 over 2 OQ. It will be 5 over 2 OQ. And then this 3 over 2 multiply with negative OP, it will be negative 3 over 2 OP. Okay, so it will be 5 over 2 multiply with OQ. This is my OQ. So minus 1, 5, 2 minus 3 over 2 OP is given. So OP 4, 7 minus 2. So here 4, 7 minus 2. Then when I multiply, 5 over 2 times minus 1 is minus 5 over 2. 5 over 2 times 5, 25 over 2. 5 over 2 times 2, it will be 5. Then minus 3 over 2 times 4, it will be 6. Then 3 over 2 times 7 is 21 over 2. 3 over 2 times minus 2, it will be negative 3. Okay, so now when you solve all the terms, you will get negative 17 over 2, then 2 and 8. So that's your position vector of R. Right? So if you want to write in word, just write position vector of R. OR equals to this result. Or probably I will just write here. Position vector of R. Alright, so we have completed this question. Okay, next question, number 10. Express this in partial fractions. So first of all, we have to check the highest degree in the numerator and denominator. So denominator, the highest degree is 3. Okay, when you do expansion, the numerator is just 2, means that this is proper rational function. That means we can solve using, we can solve the partial fractions directly. So now I will start with 21 minus 8x minus 2x squared over 1 plus 2x multiplied with 3 minus x squared. So first linear factor, therefore numerator is a constant. The second is quadratic. But I will say that this is repeating factor, okay? Repeating factor. So I will start with degree 1 and then followed by degree 2. So now my numerators will be b and c. Next step is to get the same denominator as in the left hand side. So when you compare with 1 plus 2x on the left hand side, I need to multiply with another 3 minus x squared for the first term. So I will rewrite my left hand side. So I multiply with 3 minus x squared and divide by 3 minus x squared. Now for the second term, b over 3 minus x. Now I have 3 minus x, but this is degree 1. Means that I need to times another degree 1 for first term and degree 1 for the second term. So 1 plus 2x multiply with 3 minus x over 1 plus 2x multiply with 3 minus x plus c over 3 minus x squared. So I have this squared, means you need to times with another linear factor. So 1 plus 2x over 1 plus 2x. Okay, so then now you will notice that all the denominators are the same. That means we can just ignore the denominators or cancel the denominators and write down all the numerators. Okay, after this, to find the ABC or the unknowns, the easiest way is to let the factor be 0. So I will consider 3 minus x. So when 3 minus x goes to 0, which means your x is 3. So from here, left hand side, 21 minus 8 times 3 minus 2 times 3 squared equals to, whenever you see 3 minus x, that means it will be 0. Then I can find the c directly. So 1 plus 2 bracket 3. So the left hand side will be negative 21. Then the right hand side is 7c. That means the c is minus 3. Okay, next I will let 1 plus 2x be 0. So your x is negative half. So I will get 21 minus 8 times negative half minus 2 times negative half squared equals to, now whenever you see 1 plus 2x, it will be 0, which means now I can find the a. So it will be a bracket 3 minus negative half squared. So now the left hand side is 49 over 2. And then 3 minus half is actually 3 and a half, which is 7 over 2. So you square it, it becomes 49 over 4a. Then from here, your a is 2. Okay, now to find the b, we don't have other factors, so you can let x be any other numbers as you like. So I will let it be 0. So when x goes to 0, 21, these two terms will be 0. Okay, so I will get 21 equals to, then we need to replace all the x now. So I will get 21 equals to, my a is 2, so I will direct replace. So 2 bracket 3 minus 0 is 3 squared. Then plus b is unknown. 1 plus 2 times 0 is 1. 3 minus 0 is 3. Then now my c I will replace by minus 3. So 1 plus 2x becomes 1 because your x is 0. Then now you will get 21 equals to 3 squared is 9. 9 times 2, 18. Plus 3b minus 3. So from here, 3b equals to 6. Okay. then your b is 2. So once you have found the a, b, c, just need to rewrite your rewrite your partial fractions. So I will get 21 minus 8x minus 2x squared over 1 plus 2x multiplied with 3 minus x squared. It will be a over 1 plus 2x. Now your a is 2. So 2 over 1 plus 2x. And then plus b. So b is 2 over 3 minus x. And then the c. So the c is minus 3. So we do not write plus minus 3 like this. So the plus and minus 3, just direct write minus 3. The minus, put it in the middle. It will be 3 minus x squared. So these are the partial fractions. Okay. Now next question. Hence means use the partial fractions. Obtain the expansion of fx in ascending powers of x up to and including the term in x squared. So now my fx, I will just rewrite my fx now. But since we need to do expansion, so all the denominators will be moved up. Alright, so when you move up, remember the degree becomes negative. So I will rewrite my fx. It will be 2 bracket 1 plus 2x to the power of negative 1 plus 2 bracket 3 minus x degree minus 1 minus 3 bracket 3 minus x degree minus 2. And now we need to expand up to x squared. Now, all the powers or all the degrees are negative, which means we have to use this binomial formula, binomial expansion formula. 1 plus x to the power of n, which is same as 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1. Okay, we just stop here because just up to x squared. So I will not write the next term, which is plus dot dot. Alright, 3 dots here. Now, the constant, okay, when you need to use this formula, the constant is, here must be 1. And this is plus. Okay, so there's no issue for the first term. So I will rewrite. But for the second term, this is 3, it's not 1. Means that we have to factorize a 3. So I will write 2 bracket 3 bracket. So when you factorize 3 from 3, it is 1. Factorize 3 from minus x, you will get negative x over 3. Power negative 1. Then again, for this 3, factorize a 3. You will get 1 minus x over 3. Then everything power negative 2. Okay, so now we need to do the expansion. So 2 bracket. So now, when you compare, this x becomes 2x. Okay, no issue as long as you get 1 plus. So just change accordingly. Then the n will be minus 1. So I will get 1 plus n x. N of 2x means that minus 1 times 2x plus n minus 1. So minus 1 is minus 2. Then over 2 factorial. The new x, I squared it. Okay, just up to x squared. Then for the next one is plus 2. Now, be careful with this. The minus 1 will bring into both of the terms. So when you consider degree minus 1 of 3, that is actually 1 over 3. So I will write 1 over 3. Then degree of minus 1 for 1 minus x over 3. So this 1 minus x over 3, this is actually same as, okay, I need to rewrite here. Instead of writing minus, I will write plus and put a minus. Okay, so that my b or my x here, my x in the formula becomes minus x over 3. Okay, same goes to the next one. So I will change it to, instead of minus, I will change to plus and then minus. Alright, so now use the same formula, which is 1 plus n is minus 1. Now my new x is negative x over 3. Then plus n minus 1, which is minus 2 over 2 factorial times minus x over 3 to the power 2. Okay, and the last expansion, which is minus 3, this is minus 3. So minus 3, and again, this power negative 2 will be brought into both of them. So it becomes 3 power negative 2. So 3 power negative 2 is 1 over 9. Okay, then now your new x is negative x over 3 and your n is negative 2. So I will get 1 plus n x. Okay, plus, now my n is minus 2. So then the next one is n minus 1. So minus 2 minus 1, it is minus 3 over 2 factorial. After that, minus x over 3 squared. So these are my 3 expansions. So then, next step is to simplify all the terms. So when I simplify the terms here, I will just simplify the terms inside the bracket first before I multiply with 2. So I will write 2 bracket minus 1 times 2x will be minus 2x. So 1 minus 2x. Then this whole term, when you use calculator, it will be plus 4x squared. Okay. Now for the next expansion, this is 2 over 3. So I'll get 2 over 3. And then this together is plus x over 3. And then the last term, you will get 1 over 9x squared. Okay. Now, minus 3 times 1 over 9 is minus 1 over 3. Then I will get 1 plus 2 over 3x plus 1 over 3x squared. Okay, just use calculator to calculate the values. Then now, next step is do expansion. So bring in all these terms to the brackets. So I will get 2 minus 4x plus 8x squared, then plus 2 over 3 plus 2 over 9x plus 2 over 27x squared minus 1 over 3 minus 2 over 9x minus 1 over 9x squared. So simplify the terms. So the constant will be 7 over 3, followed by the next term is negative 4x, and then last term is 215 over 27x squared. So here I should write plus dot dot dot. So these are the 3 terms. Okay, or I would say that this is the expansion up to x squared. Okay, now question 11. The complex number z is defined by 5a minus 2i over 3 plus ai, where a is an integer. Given the argument is negative 1 over 4 pi. Find the a and hence express the complex number in the form of x plus yi, where x and y are real number. Okay, so now first of all, I need to multiply the conjugate of the denominator first, because you have the I in the denominator. So the conjugate is 3 minus 2i. Sorry, the conjugate is 3 minus ai, right? So now we do the expansion. So for the denominator, if a complex number multiplied by its conjugate, the answer, the multiplication is a squared plus b squared, which means it's a real part squared plus imaginary part squared. So now my real part is 3. So I will write 3 squared. Imaginary part is a. So plus a squared. And the numerator, just do expansion. So 5a times 3, 15a. 5a times negative ai. Okay, so it will be negative 5a squared I Then negative 2i multiplied by 3, it will be negative 6i. Minus 2i times negative ai. So I squared is minus 1. So I is minus 1, then times by another positive, it will be negative 2a. Okay, so when you do expansion, it will be negative 2a. So from here, alright, or probably you can write plus ai also can, no problem. So ai later you change to minus 1. This is minus 1. So it means that now I will get 15a minus 2a, right? And then plus I minus 5a squared minus 6 over 3 squared plus a squared. Now we know that complex number always written in real and imaginary parts. Therefore, 15a minus 2a is 13a, then over 9 plus a squared. Then instead of both minus, you can just take it out. It will be minus of 5a squared plus 6 over 9 plus a squared. Then this is I. Okay. Now I'm going to use the argument, which is minus 1 over 4 pi. So when the argument is negative 1 over 4 pi, means that your complex number is here. This is your complex number. This is pi over 4. It is below the real axis because your argument is negative. So argument is found using inverse tangent y values. So it will be negative. Okay, just for information, argument is inverse tangent b over a if your complex number is a plus bi. Alright, so now my b is 5a squared plus 6, negative 5a squared plus 6 over 9 plus a squared. This is my imaginary part. So I will write negative 5a squared plus 6 over 9 plus a squared, then divided by 13a over 9 plus a squared. That will be negative pi over 4. So inverse tangent negative is same as negative inverse tangent. Okay, so this from here, the denominators are the same, then I can cancel off. Which means, right, 5a squared plus 6 over 13a will be tangent pi over 4. Because on minus, this minus can be taken out. Then the minus from both sides will be cancelled off. So tangent pi over 4 is basically 1. Then now 5a squared plus 6 equals to 13a. Move the 13a to the left hand side. So 5a squared minus 13a plus 6 equals to 0. And now we can factorize this quadratic into two linear factors, a minus a and 5a minus 3. So my a equals to 2, or I will write a minus 2 equals to 0, or 5a minus 3 equals to 0. My a either 2 or 3 over 5. Okay, so now which a that we need to accept, because value means 1a, and then is given a is integer. So now given that a is an integer, therefore the a is 2. Okay, we cannot accept 3 over 5. Now after you have found the a, we need to get the complex number in x plus iy form. So we have solved here. This is our complex number. What to do next is just to replace the a value. Right? So your complex number, it will be 13a. Now your a is 2. So 13 times 2 over 9 plus a squared. So 9 plus 2 squared minus 5a squared plus 6. So 5a squared plus 6 over 9 plus a squared I. So then you will get 26 over 13 minus 26 over 13i. At last, it will be 2 minus 2i. So that is your complex number. Okay. Now, B, express z cubed in the form REI data where r is greater than 0, theta is between minus pi and pi, inclusive pi. Give the simplified exact values of r and theta. So now I will rewrite. My complex number is 2 minus 2i. So instead of getting, in order to get the z cube in REI data, I will express my complex number 2 minus 2i in REI data first. Okay, so now my r is square root of real part squared, which is 2 squared, plus imaginary part squared, which is square root of 4 plus 4. And then I will get square root 8. So this square root 8 is basically 2 square root 2. Okay, now the theta is already given, which is the argument. This is negative pi over 4. It's given in the question. So now my complex number can be written as 2 square root 2e negative pi over 4i. Because it's I theta. And now you need to express z cube. Okay, so I just need to cube it. So it will be 2 square root 2 e negative pi over 4i cube. So this cube will be brought into the brackets. The first is for the angle, the second is for the r. So I will get 2 square root 2 cube exponential. Now for your information, if exponential a to the power of b, it will be EAB. Okay, so I will just direct times the 3 with negative pi over 4i. So I will get negative 3 over 4 pi I. Now for the r, this is my I. So cube of 2 square root 2 is basically 16 square root 2. You can get it from calculator. And this is e negative 3 over 4 pi I. So that is my z cube in the form of REI data. Okay, alright, so we have solved this whole paper. Thank you for watching this video. Please subscribe to my YouTube channel if you enjoy watching my video, and stay tuned for more upcoming videos. Thank you, bye.